Hello everybody, today we will talk about chapter 10, game theory. The first, we need to know the definition of the game theory. What is the game theory and what is it talk about? It's a general framework to aid decision making when agents' payoff depends on the action taken by others. In this course, we will have a graph to help us make a better decision or through several game strategy to help us to making a decision in a marginal managerial economics. And we will have several types of game also as the games we played in our life, like poker game or um, a board game or something. The first one is a simultaneously move game. Same as the name, it's just a game you you doing only it's the game in which each player make decision without the knowledge of the other player's decisions. For example, you playing a game and you need to make decision uh, with your with other player at the same time. And the second one is sequential move game. Uh, this is a game in which one player makes a move after observing the other player's move. That means when the action you will take is according to the other player's action. And the third one is one-shot game. That means this is a game in which player interact to make decision only once. That means this game only have one chance. And the number four is repeated game. It's a game in which the same players interact to make decision more than once. Same as the game called Monopoly, and you need to roll a dice once in more than once time. And I will introduce you what is the definition of strategy and normal form game. Strategy is a decision rule that describes the actions a player will take at each decision point. Like what kind of plan you will take in this game, what kind of strategy you will act in this game. And number two is normal form game is a representation of a game indicating a player their possible strategy and the payoffs resulting from alternative strategy. We also call normal form game to payoff metric. It's a graph to show all the possibilities from both players and what can you get, how possible you can win this game. This metric help us to do better prediction or more accurate, more possible decision. And I will introduce three different kind of strategy mainly used in our chapters. The first one is dominant strategy. It's a strategy that results in the highest payoff to a player regardless of the opponent's action. That means whatever others make their decisions, you only pick the highest payoff you will get. And the second one is secure strategy. This is a strategy that guarantees the highest payoff given the worst possible scenario. We also call this strategy max-min strategy. That means under the worst scenario, what can you get the highest payoff in this game? And the third one is Nash equilibrium strategy. This is a condition describing a set of strategy in which no players can improve her payoff by unilaterally changing her own strategy given the other player's strategy. In conclusion, Nash equilibrium strategy is find out a set of strategy that is better off for both players. But we will discuss there are two shortcomings of secure strategy. Of course, secure strategy is the most securely when you play a game that will keep you at least to gain something, but still have shortcoming. The first one is this is a very conservative strategy and should be considered only if you have a good reason to be extremely averse to risk. If you really scare risk, you just want to keep safe at this situation, you might choose this strategy. And the second one, this strategy does not take into account to the optimal decision of your rival and thus may prevent you from earning a significant higher payoff. When you're doing your secure strategy, that means you still have the part of a chance to get a higher payoff, but you get rid of this chance to have a higher payoff. And we are already knowing how to find out the Nash equilibrium. In some situation, it makes some question about Nash equilibrium. So the first one is, if a game has no dominant strategy, do we still have Nash equilibrium in this game? To explain the scenario, let's imagine that in a simply games, we always have a dominant strategy to rule out some other strategy, and then you are easier to figure out which one is Nash equilibrium. But if in a game there is no dominant strategy, is that still have Nash equilibrium in this game? The answer is yes. And the second one is, well, we have only one Nash equilibrium in a game. The answer is no. We may have several Nash equilibrium. It might be 2 or 3 or several or more, because there may be several Nash equilibrium, the set of strategy, player A or B have no reason to move to other strategy, but they are still better off. Yeah, that's all I talk about the chapter 10. Thank you.